In this video, I'm going to explain the force distance graph. I'm going to do the second example of a force distance graph taken from a question paper of April 2023. 4.2. A cable is used to hoist a lift with a mass of 250 vertical up to a height of 80 meters. The mass of the cable is 3 kg per meter. First question, draw a force distance graph using the above information. It is a force distance graph. So first thing, you need to convert or to change these two to newtons. Let's look at the solution. A force distance graph. To change kilograms to newtons, you multiply by 9,8, and this will be the weight of the lift in newtons. Weight of the cable, 3 times 9,8. It will be 29.4 per meter because you are given is 3 kilograms on a single meter. But if you want this weight of the cable for the total of 80 meters, you're going to multiply this answer by 80. So it's 29.4 multiplied by 80. To get the answer, 29.4 multiplied by 80, it will be 2352. 2352 newtons. On a single meter, it's 29.4, but over 80 meters, it will be 29.4 multiplied by 80, and this is the total. So the lift, its weight is not going to change at any position. So the graph for the lift alone, it will be constant. It's not changing. So here there is 2450 lift alone. The cable is going to start at 80 meters as it is lifting up this load. The cable will be getting shorter until the total length of the cable has been hoisted up. So from this distance, it's going to start at 80, then it's going to get shorter until the total length is hoisted up. So what we have on top or at the end, it will be the combination of the two. We're going to have both the cable and the lift. So the answer for that, or what we plot there, is 2450 plus 2352. The answer is 4802. 4802. That is the first question, the total, sorry, sketching the graph. Number 2, calculate the total work done using the graph above. Total work done is the area under the graph, so W will be equal to A1 plus A2. We can label this A1 and this one A2. So the formula to calculate A1 is L times B, and that of calculating A2 is half times base times height. Dimensions of A1 is 2450 multiplied by 80. This by this. And plus half multiply the base of the triangle is 80. And the height of the triangle, which is this base, it is this 4802 minus 2450. In other words, the height of the triangle is equal to the total weight of the chain. Because when you subtract this from this, you're going to get this answer. So it will be multiplied by 2352. Use your calculator to get your answer. This is 196,000, and this one will be half multiplied by base multiplied by 2352. The answer is 94080. Then we plus the 2. This will be plus 196,000. Is 290080. 290080 joules. That is work done. So a question can say, calculate the work done in kilojoules. So a kilo, you divide by 1,000. This will be 290 kilojoules. Only if a question specifies what units must be your final answer. Second question is looking for the tension on the cable. Question number 3, average tension in the cable. So to calculate the tension, a tension or the average between two forces. Number 3, we can say is T average or F average would be equal to F1 plus F2 divided by 2. That is the average tension. So the first tension we have is 2450, and the second one is 4802. We divide both by 2. You use your calculator to calculate the average tension is 2450 plus 4802, then you divide by 2 to get the average is 3626. So it will be equal to 3626 newtons. So it is the value that falls between these two. Now the average, if a question says show it on the graph, on the distance side, the average would be 80 divided by 2, which is equal to 40. Then it will correspond with this value on this side, which is 3626. So this is the average at this point. Now you can calculate work done using the average, because work done is a force multiplied by distance. So this force is the average force or the average tension. So it is 3626 multiplied. The distance is 80. Use your calculator to multiply this answer by 80 and you get the same answer. Which is 290080 joules, or you can put it in kilojoules. Last question says, determine the power required when the load is 50 meters from the bottom and the velocity is 0,43. Sometimes you can be given time. When you're given time to calculate power, it means power will be equal to work done over time. When you are given velocity, power will be equal to force multiplied by velocity. And this force here is the average. Also, you can calculate using this formula by calculating time first. You can use the given velocity to calculate the time first. Now, power required when the load is 50 meters from the bottom. There's a power required to hoist the remaining length of the chain when the load is 0,43 meters from the bottom. Now let's go to the graph. To answer that question, you must sketch a second graph that starts at 50 meters to 0. So this is number 4. For number 4, you need a second graph. This second graph must have, we can put 10, 20, 30, 40, 50. So even if it is at 50 meters, the weight of the lift is not going to change. But the chain is getting shorter and shorter until that point. So this one will remain 2450. But the total we plot there cannot be that total when it was 80 meters. So we need to get what is the total of the chain if now it is at 50 meters. To get that total, we use the chain per meter, the weight of the chain per meter. The weight of the chain per meter is 29,4. So the weight of the chain will be equal to 29,4 multiplied by, we no longer want it for 80 meters, but it's needed for 50 meters. So you multiply this by 50 to get what is the weight of the chain for the new graph. Because you want the work that is required to hoist the remaining length of the chain when it is at 50 meters. In some question, they will say, instead of saying when it is 50 meters, they will say when it is 20 meters from the drum. The drum is what is rolling up the load. So sometimes they can give you a distance from the top. Sometimes they can give you a distance from the bottom. So it's 29.4 times 50. 29.4 multiplied by 50. The answer is 1470. 1470 newtons. So this answer is what we add here to get the total, because what we plot here is the combination of the load and the cable. So it will be plus 2450. The answer is 3920. So this is 3920. Now you have two methods of calculating this power. You can use area 1 and area 2 to get work done. After getting the work done, you use the given velocity, which is V equal to 0,43 meters per second, and calculate time. To calculate the time, V equal to S over T. And you make T the subject, which will be equal to distance. You are focusing at 50 meters. So it will be 50 divided by the velocity is 0,43. Then time will be equal to 50 divided by 0,43. The time will be 116,279. 116,279 seconds. So this will be the time. Now, if you calculate time first, it means we're gonna need these areas so that we can use work done and the time. So in order to use that formula of work done and time, to calculate work done of this new graph, it will be A1 plus A2. Area 1 is L times B plus a half times base times height. This is 2450 multiplied by 50 plus a half times the base of the triangle is 50. But the height of the triangle will be difference between the two. 3920 minus 2450 is going to give us this answer. It's 1470. Use your calculator to get the answer. 2450 times 50. $24.50 times 50 is equal to 122,500 plus half times 50 times 1470. This is 36,750. Then you plus the 122,500. The answer is 159,250 joules. That is the work done. So we can calculate power equal to work done over time, which is 159,250 divided by value of time is 116,279. And the answer here is is 1369. 1369.551. 0.551 watts. If you change it to kilowatts, this is 1,36 kilowatts. Alternatively, to calculate power, we can use P equal to F average multiplied by velocity. Average force of the new graph. F average, which will be equal to 2,450 plus 3,920 divided by 2 is F1 plus F2 divided by 2. So the average is 2,450 plus 3,920 and all divided by 2. It will be 3,185 newtons. So we substitute this side, 3,185 multiplied by 0,43. The answer here, when we multiply by 0,43, it is 1369. 1369,55. 1369,55 watts, which is the same answer as this one. Or is 1,37 kilowatts. So when calculating power, you can use time or you can use the velocity. Keep in mind that when we are using velocity, a force must be the average force. When you want to use work done over time and the distance is not the total, if the question was calculate it to power required to raise through the 8 meters, we're going to take this work done. We're going to take this work done, this, and divide it by given time. But since the condition has changed, you must sketch the new graph for that condition. Thank you.